Let's jump straight into the deep end. We're looking at the guest list for the Third World Conference on Artificial Consciousness. This isn't just any conference. It's aiming to be the place where the biggest minds in this field meet and debate. Think of it as the ultimate summit for figuring out if machines can think, or at least, what that even means. So who are we trying to invite? The goal is pretty ambitious: get the top thinkers globally. We're talking about roughly 100 experts. And the bar is set incredibly high. They need to be laureates of the Nobel Prize, the Turing Award, or the Fields Medal. Think of these as the Oscars of science and computing. These aren't just any academics. They're the legends, the pioneers who fundamentally shaped their fields. Plus, they have to be active researchers, still pushing the boundaries. The list gives you all the essentials: who they are, what award they won, where they work, what they might talk about, why we think they should speak, how they'd likely join, and how to reach them. It's all organized neatly by discipline, so you know who's who. First up, let's dive into the computer science and AI camp. This is the heartland of building intelligence. We're talking about the folks who actually write the code, design the algorithms, and build the machines. Most of these names are synonymous with the Turing Award, often called the Nobel Prize of Computer Science. They're the heavyweights in areas like deep learning, reinforcement learning, figuring out cause and effect, and the fundamental theory of computation. Their work is crucial because it directly tackles the question: how does artificial intelligence relate to consciousness? Can we build a machine that's not just smart, but aware? Given their busy schedules, especially with some being based far away, the plan is mostly online talks, but we'll try to bring the biggest stars in person if possible. Let's look at the first batch of CS and AI stars. You see Yoshua Bengio, Geoffrey Hinton, and Yann LeCun right there. These three are the three giants of deep learning, sharing the 2018 Turing Award. They basically built the modern era of AI. Bengio is leading Mila, a powerhouse AI research institute in Montreal. Hinton, the godfather of deep learning, recently made headlines by winning a Nobel Prize in physics. Yes, physics, for his work on neural networks. LeCun is the chief AI scientist at Meta, the company behind Facebook, and also a professor at NYU. Then there's Andrew Bardo, another Turing winner, known for his foundational work in reinforcement learning. These are the titans shaping the field today. Next wave. Richard Sutton, another 2024 Turing winner, is a giant in reinforcement learning, the kind of AI that learns by trial and error, like AlphaGo or ChatGPT. Judea Pearl, 2011 Turing winner, is legendary for bringing causal reasoning to AI, helping machines understand why things happen, not just what happens. Leslie Valiant, 2010 Turing winner, is a master of computational learning theory, asking fundamental questions about what can be learned efficiently. And Edward Feigenbaum, 1994 Turing winner, is considered a pioneer of early AI systems, specifically expert systems, which tried to capture human knowledge in machines. Notice Feigenbaum is listed as retired, which is important for planning how to involve him. Continuing our tour of CS and AI luminaries. Raj Reddy, a 1994 Turing winner, was a pioneer in making AI interact naturally with humans, think early voice recognition, and robotics. Manuel Blum, 1995 Turing winner, is a giant in computational complexity theory, figuring out the limits of computation. John Hopcroft, an 1886 Turing winner, is another algorithm superstar, known for his work on data structures and, more recently, brain-inspired computing. And Andrew Yao, the 2000 Turing winner, is a leading figure in computational complexity and cryptography, and a major force in Chinese computer science, promoting interdisciplinary research like quantum computing and machine learning. Again, note Yao's affiliation with Tsinghua University in China. And the final group in CS and AI. Demis Hassabis, co-founder of DeepMind, the company behind AlphaGo and AlphaFold. He's not a Turing winner himself, but his impact is huge, and he won a Nobel Prize in Chemistry in 2024 for AlphaFold. That's incredible. Tim Berners-Lee, the inventor of the World Wide Web, a 2016 Turing winner, thinking about the future of distributed intelligence. Ivan Sutherland, the father of computer graphics, an 1888 Turing winner, who literally created the first VR headset. Tony Hoare, a 1980 Turing winner, a pioneer in programming languages and formal methods. And Dana Scott, a 1976 Turing winner, a founder of domain theory and lambda calculus, deeply involved in the logic of computation. Many of these later figures are retired, so flexibility in participation format is key. Let's zoom in on Yoshua Bengio. His suggested talk title is Deep Learning and Artificial Mind, From Neural Networks to Consciousness Emergence. Why him? Because he's one of the three giants who basically invented the current deep learning revolution. He leads Mila, a massive AI research hub in Canada, and he's a big advocate for responsible AI. His talk would explore how these powerful deep learning techniques, which are inspired by the brain's neural networks, might lead to something akin to consciousness. He's uniquely positioned to bridge the gap between cutting-edge AI achievements and the philosophical quest for artificial consciousness. Since he's based in Canada, an online speech seems most practical. Next, Geoffrey Hinton, the godfather of deep learning. His title is From Boltzmann Machines to GPT, The Physics Path of AI and Consciousness. Hinton is legendary. He's not only a Turing winner but also shared a Nobel Prize in Physics in 2024 for his work on neural networks. He introduced concepts from physics, like Boltzmann machines, into AI, which was revolutionary. Now he's deeply concerned about AI safety and the potential for superintelligence. His perspective is unique. He has both the technical know-how and the philosophical courage to ask the big questions, like can machines truly possess consciousness? Given his retirement and focus on safety advocacy, he might prefer an online talk or even a pre-recorded video. Now for Yann LeCun. His title is Self-Supervised Learning and Self-Awareness, the Next Step for AI. LeCun is another giant, a Turing winner, and currently the chief AI scientist at Meta. He's a huge proponent of self-supervised learning, which is a way for AI to learn without needing tons of labeled data, much like humans learn. He's famous for his work on convolutional neural networks that revolutionized computer vision. LeCun is very optimistic about achieving artificial general intelligence and believes AI needs to learn world models autonomously. This idea of self-learning, self-awareness, is right at the heart of the quest for artificial consciousness. An online talk fits well with his schedule. Andrew Barto, another 2024 Turing winner. His title is Reinforcement Learning, From Animal Behavior to Agent Consciousness. Barto is a foundational figure in reinforcement learning, the type of AI that learns by getting rewards or penalties for actions, like a rat learning to navigate a maze. He developed core algorithms like temporal difference learning and Q-learning. This field beautifully connects psychology, how animals learn, with computer science. For understanding artificial consciousness, RL is key because it deals with agents learning, adapting, and making decisions based on their environment. Barto can explain how this trial and error process might lead to something resembling consciousness or autonomous will. Online is the recommended mode. Richard Sutton, another 2024 Turing winner and Barto's collaborator. His title is Prediction and Control, a reinforcement learning framework for solving the mystery of consciousness. Sutton is arguably the founder of the modern RL field. He developed influential methods like policy gradients and Dyna architectures, and his textbook is the Bible for RL. His core idea is that intelligence comes from an agent constantly predicting the future based on its interactions with the environment. This prediction control loop is similar to how we perceive and act. Sutton's work explores how agents build internal models of themselves and the world through this process. Could this be a pathway to artificial consciousness? His insights are invaluable. Mostly online participation is suggested. Judea Pearl, the 2011 Turing winner. His title is Causal Reasoning and Machine Self-Awareness: How AI Understands Causality. Pearl is a giant in making AI reason about cause and effect. Before Pearl, AI was mostly stuck looking at correlations. He developed tools like Bayesian networks and the do calculus, allowing machines to ask what if. Questions like, what if I did X, would Y happen? This ability to understand causality is seen as a hallmark of human-like intelligence and consciousness. Pearl's work allows us to endow AI with deeper cognitive abilities, moving beyond pattern matching to understanding relationships. Given his age, an online talk is preferred. Leslie Valiant, the 2010 Turing winner. His title is Computational Learning Theory and Brain Models: Computable Mind? Valiant is famous for creating PAC learning theory, which provides a mathematical foundation for understanding what concepts can be learned efficiently by machines. He's also explored the circuit complexity of the brain, trying to understand the computational power of biological neural networks. His work fundamentally asks, what is learnable? This perspective is crucial for artificial consciousness because it helps us determine if consciousness itself is computable, if it can be represented as some complex function that a machine could potentially learn or simulate. An online talk is suggested. Edward Feigenbaum, the 1994 Turing winner. His title is Inspirations from Expert Systems, Knowledge Representation, and Artificial Consciousness. Feigenbaum was a pioneer in early AI, specifically in creating expert systems like Dendril and Mycin. These systems tried to encode human expertise into rules and logic. While different from modern deep learning, they were crucial in exploring how to represent knowledge in machines. His work provides valuable historical perspective. How do we combine structured knowledge with learning algorithms? How can a machine have both explicit reasoning and implicit intuition, like a human? This is relevant to building more sophisticated forms of artificial consciousness. Due to his age, mainly online participation is suggested. Raj Reddy, the 1994 Turing winner. His title is Multimodal Interaction and Embodied Intelligence, from voice recognition to cognitive robots. Reddy was a pioneer in making AI interact with humans in natural ways, like understanding speech and controlling robots. He foresaw the importance of context and perception, ideas that resonate strongly with the embodied cognition approach in consciousness research, which argues that the body plays a crucial role in cognition. He can share insights from developing early voice assistants and robots, discussing how AI can gain human-like cognitive experiences by perceiving and acting in the world through multiple senses. Online participation or a pre-recorded video is suitable. Manuel Blum, the 1995 Turing winner. His title is Conscious Turing Machine, an artificial consciousness framework from the perspective of theoretical computing. Blum is known for his work on computational complexity, but he and others have proposed a fascinating concept called the Conscious Turing Machine, CTM. This is an attempt to use the rigorous tools of theoretical computer science to model aspects of consciousness, like attention and self-awareness, inspired by theories like global workspace theory. It's a bold attempt to bring the precision of CS theory to the messy problem of consciousness. Blum's work shows that theoretical computer science can offer concrete frameworks for thinking about artificial consciousness. An online speech is suggested. John Hopcroft, the 1886 Turing winner. His title is A Brief History of Brain Computation, from Algorithm Theory to Neural Networks. Hopcroft is a legendary figure in algorithms and data structures. More recently, he's turned his attention to brain-inspired computing models, trying to understand the brain as a computational network using algorithmic principles. He uses computational theory to analyze how neural circuits work. His perspective is incredibly valuable for bridging the gap between the engineering of AI and the theoretical analysis needed for understanding consciousness. He can offer profound thoughts on the fundamental nature of computation and intelligence. If possible, an offline speech would be great, especially if the conference is in Asia, where he's influential. Otherwise, online participation. Andrew Yao, the 2000 Turing winner. His title is Computational Boundaries and Intelligence Leaps, Quantum Computing, Cryptography, and the Future of AI. Yao is a towering figure in computational complexity and cryptography. He's a leading voice in Chinese computer science and promotes interdisciplinary research, including quantum computing and machine learning at Tsinghua University. His work on computational limits is directly relevant to artificial consciousness. What are the fundamental barriers? Can we break them? Could quantum computing or entirely new algorithms unlock higher levels of artificial intelligence or wisdom? His strategic vision offers a macro perspective on the future of AI. An offline speech would be highly appealing, especially if the conference is in China. Demis Hassabis, co-founder of DeepMind. His title is The Road to Artificial General Intelligence, Inspiration Crossing Computation and Neuroscience. Hassabis is a key figure in the practical pursuit of AGI. He led DeepMind's teams to landmark achievements like AlphaGo beating the world champion in Go and AlphaFold solving protein folding. Although not a Turing winner himself, his leadership earned him a Nobel Prize in Chemistry in 2024 for AlphaFold. He's uniquely positioned to discuss the real-world path towards AGI and the interplay between computation and neuroscience. AlphaFold itself demonstrates AI's incredible potential for complex scientific discovery and emergent behavior. His presence would be a major draw, ideally in person or via livestream if not feasible. Tim Berners-Lee, the inventor of the World Wide Web, a 2016 Turing winner. His title is the World Wide Web and Distributed Intelligence, the embryo of a global brain. Berners-Lee, the guy who gave us the internet as we know it, now thinks about the semantic web and decentralized networks. He has a grand vision for the future of AI. His talk could explore how the internet functions like a global brain and whether such a vast distributed system might exhibit characteristics akin to holistic consciousness. This offers a completely different angle on artificial consciousness, focusing on distributed intelligence rather than individual agents. An online speech is suggested. Ivan Sutherland, the 1988 Turing winner, known as the father of computer graphics. His title is Virtual Reality and Consciousness Illusions, Inspirations from Computer Graphics for the Mind. Sutherland literally invented the first VR headset, the Sword of Damocles. His work in computer graphics and VR is groundbreaking. VR technology works by creating illusions that fool our consciousness into perceiving a virtual reality. Studying how VR affects our sense of self and reality is a fantastic way to probe the nature of consciousness itself. Sutherland's experience can inspire us to use immersive technologies to test and simulate artificial consciousness. An online interview format might work well for sharing his insights. Tony Hoare, Sir C. A.R. Hoare, the 1980 Turing winner. His title is Formal Logic, Algorithm Verification and AI Ethics, Can Machines Prove Themselves? Hoare is famous for Hoare logic and CSP, which are ways to formally verify that programs do what they're supposed to do. This is critical for trustworthiness, especially in AI. In the context of artificial consciousness, ensuring the correctness and interpretability of a machine's behavior is paramount. Hoare's work on formal logic can be adapted to create mechanisms for machine self-censorship or ethical constraints. He might even ponder whether a conscious AI could formally verify that its own behavior aligns with ethical norms. Online participation is suggested due to his age. Dana Scott, the 1976 Turing winner. His title is Logic, Language, and Mind, Artificial Consciousness from the View of Mathematical Logic. Scott is a founder of domain theory and made significant contributions to the semantics of programming languages using lambda calculus. Mathematical logic provides powerful tools for describing states and processes. His perspective can help us explore the formalizability of consciousness. Can subjective experience, qualia, be described in a logical language? How can formal verification techniques ensure that a machine's behavior consistently matches the intended properties of consciousness? An online discussion format would be appropriate. So, wrapping up the computer science and AI section. Bringing together these diverse minds, from the pioneers of deep learning to the architects of formal logic, creates a powerful intellectual collision. Their combined expertise in algorithms, computation, and the very definition of intelligence will provide a rock-solid foundation for the technical and theoretical challenges in building artificial consciousness. It's about understanding the how and what of intelligence from a computational perspective. Now, let's shift gears to neuroscience and cognitive science. This is where we look inside the brain to understand consciousness. We're talking about the Nobel laureates who've made groundbreaking discoveries about memory, perception, neural circuits, and even brain-computer interfaces. Their work directly informs how we can try to simulate brain functions in AI. Think about mapping memory locations, understanding how we perceive the world, how neurons talk to each other, and how we can even control devices with our thoughts. However, many of these scientists are quite senior, so we'll need to be flexible, likely relying on online formats, and perhaps inviting their younger colleagues to participate in discussions. Here's a glimpse of the neuroscience and cognitive science delegation. You can see the structure, names, affiliations, contact details. The focus here is on those who've used experimental methods to unlock secrets of the brain and mind. Their findings are incredibly relevant for anyone trying to build artificial consciousness, as they reveal the biological substrate of awareness. Let's meet some of the stars in this field. The Mosers Edvard and May Britt, along with John O'Keefe, won the Nobel Prize in 2014 for discovering place cells and grid cells, the brain's internal GPS system. Susumu Tonegawa, Nobel Prize winner, famously manipulated mouse memories using genetic tools. Thomas Südhoff, Nobel Prize winner, figured out how neurons communicate across synapses. Ardem Pataputian, Nobel Prize winner, discovered how we sense touch and pressure. Richard Axel and Linda Buck, co-winners of the Nobel Prize, decoded the sense of smell. And then there's John Hopfield, who we also saw in the CS section, a pioneer in computational neuroscience and winner of the 2024 Physics Nobel. Kite a lineup. Edvard Moser, co-discoverer of grid cells. His suggested title is The Brain's Internal GPS's Spatial Cognition and AI Navigation. The Mosers won the Nobel for figuring out how the brain creates a map of space using grid cells. It's an incredibly efficient system. Moser's work suggests that the brain achieves this with minimal energy. This is fascinating for AI. Imagine designing robots or autonomous systems that can navigate complex environments as effortlessly as we do. His talk would explain how the brain generates these spatial representations and how AI could potentially mimic this cognitive map for better navigation and environmental understanding. Online with Q&A is the plan. May-Britt Moser, Edvard's wife and co-discoverer. Her title is The Spatial Dimension of Memory, From Location Encoding to Episodic Consciousness. While the Mosers are famous for the brain's GPS, May-Britt also studies how the brain links space and time to form episodic memories, our memories of specific events. This is crucial because memory is deeply tied to consciousness. Her research shows how our sense of location influences how we remember things. This has direct implications for AI. How can an agent build a continuous sense of self and memory of its experiences? An online participation format, possibly with video footage of their experiments, would be ideal. John O'Keefe, the third Nobel winner in this trio. His title is Place Cells and Cognitive Maps, How Neural Coding Shapes Experience. O'Keefe was the pioneer who first discovered place cells in the hippocampus, neurons that fire when an animal is in a specific location. This laid the groundwork for the cognitive map theory, the idea that the brain constructs an internal representation of the external world. For AI to have any kind of autonomous consciousness, it would need similar mechanisms to represent its environment and its own position within it. O'Keefe can delve into how these neural codes generate our subjective experience of space. Due to his age, an online speech is preferred. Susumu Tonegawa, the 1987 Nobel Prize winner in immunology who switched to neuroscience. His title is Capture and Manipulation of Memory Traces, Inspirations for Artificial Minds. Tonegawa's lab used ingenious genetic tricks to tag and reactivate specific groups of neurons that hold memory traces or engrams in mice. This proved that memories are stored in specific assemblies of neurons. Since memory is a core component of consciousness, understanding how it's stored and retrieved is vital. Tonegawa's work shows that memory can be precisely targeted. This raises a key question for artificial consciousness. Can we design AI systems with similarly addressable memory units to store and recall experiences? An online report with discussion is suggested. Thomas Südhoff, the 2013 Nobel Prize winner. His title is Symphony of Synapses, The Genesis of Consciousness from Neural Communication. Südhoff's Nobel was for figuring out the molecular machinery that allows neurons to communicate across synapses, the tiny gaps between nerve cells. His work explains how neurotransmitters are released and how connections strengthen or weaken, which is the basis of learning and memory. This is fundamental for artificial consciousness because it reveals how information flows and is processed in the brain. Südhoff's research shows that the brain sculpts memory and learning by tweaking these connections. This inspires AI to simulate consciousness by dynamically adjusting the strengths of connections in its network. An online speech is suggested. Ardem Pataputian, the 2021 Nobel Prize winner. His title is Touch and Proprioception. Where does awareness come from? Pataputian discovered the receptors that allow us to feel touch and pressure, like the piezo channels. His work explains how the body translates physical forces into nerve signals. This is critical because consciousness is deeply intertwined with our perception of our own body and the world around us. Our sense of touch is a primary source of subjective experience. Pataputian's discoveries can guide how we give robots, or AI, a form of body sensation, perhaps using skin-like sensors, to develop a primitive form of conscious perception. An online speech is suggested. Richard Axel, co-winner of the 2004 Nobel Prize with Linda Buck. His title is Olfactory Coding and Perceptual Consciousness: How the Brain Understands the World of Sense. Axel and Buck figured out how we smell. Axel discovered the genes for olfactory receptors and how the brain decodes the complex chemical signals from the air into the rich world of smells. This research highlights the importance of sparse coding and pattern recognition in sensory consciousness. For AI, effectively encoding high-dimensional inputs like images, sounds, or smells is essential for generating anything like a conscious experience. Axel can discuss how the brain turns complex chemical signals into our subjective experience of smell, inspiring AI to simulate multimodal perception. Online participation is suggested. Linda Buck, Axel's collaborator and co-Nobel laureate. Her title is The Sensory World and Subjective Experience: Artificial Perception from the Perspective of Olfactory Mapping. Buck's work focused on mapping how the olfactory system projects from the nose to the brain. She showed how the brain organizes sensory information into spatial maps, like the map in the olfactory bulb, which is closely linked to our subjective experience of smell. For artificial consciousness, we need to figure out how to organize sensor inputs into meaningful internal representations that could give rise to subjective feelings about the environment. An online speech or dialogue would be suitable. John J. Hopfield, the 2024 Nobel Prize winner in physics, appearing again. His title is Memory Networks and Energy Landscapes: Consciousness Models in the Eyes of Physics. Hopfield is a pioneer in computational neuroscience, famous for the Hopfield Neural Network, a model of memory that uses principles of energy minimization. His network shows how the brain might retrieve memories by finding stable states like attractors in a landscape. He compares complex neural activity to optimizing an energy function, relating it to the stable state of consciousness. His physics background provides a unique lens to analyze memory and consciousness states in both brains and machines. An online report. Let's meet some of these heavyweights. We've got Nobel laureates in physics like Roger Penrose, famous for his wild ideas about quantum consciousness, and Giorgio Parisi, who cracked the code on complex systems like spin glasses. Then there's Brian Josephson, another Nobel winner who dared to explore the link between mind and matter. Frank Wilczek, a Nobel physicist known for his popular science writing and philosophical bent. On the math side, Fields medalists like Stephen Smale, who foresaw the rise of machine learning, and David Mumford, who bridged math and computer vision. Cedric Villani, another Fields medalist, brings a policy perspective. And Jean-Marie Lannes, a Nobel chemist whose work on self-organizing molecules is incredibly relevant. Finally, Stuart Russell, a leading voice in AI ethics, even though he doesn't have the top awards listed here. Each brings a unique angle to the table. Let's start with Roger Penrose. This guy is legendary. He won a Nobel for figuring out black holes, but he's also famous for arguing that human consciousness isn't just computation. He uses Gödel's incompleteness theorems, basically showing that formal systems have limits, to suggest our minds do something algorithms can't. His controversial idea? Quantum mechanics is involved. He proposes that tiny quantum effects happening inside brain cells, specifically in microtubules, are the source of consciousness. Now, many scientists scoff at this, but that's exactly why he's valuable here. He forces us to confront the possibility that consciousness might be fundamentally non-computational, challenging the very idea that AI could ever truly replicate human awareness. Since he's over 90, they're thinking of an interview or playing a recording, but his ideas are definitely worth hearing. Next up, Giorgio Parisi. He's a master of finding hidden order in seemingly chaotic systems. Think about things like spin glasses, materials where magnetic spins are jumbled up randomly. Parisi showed that even in this mess, there are underlying statistical laws. His big insight is that complex systems, while unique, often follow universal patterns. How does this relate to consciousness? Well, artificial consciousness could be seen as an emergent phenomenon, something that pops up from the complex interactions within a system. Parisi helps us understand how simple rules, like those governing particles in a spin glass, can lead to incredibly complex behaviors, like intelligence, or maybe even consciousness. He might talk about swarm intelligence, how birds flock, or self-organized criticality, where systems naturally hover at a tipping point. This helps us think about how brains, or even AI, might develop representations of the world that feel conscious. Now for Brian Josephson, another Nobel winner, this time for discovering the Josephson effect in superconductivity. But then he did something radical. He turned his attention to the age-old problem of mind and matter. He founded the Mind-Matter Unification Project. What's fascinating is his openness. He's not afraid to consider connections between quantum physics and consciousness, even touching on topics like paranormal phenomena. As a respected physicist venturing into this mysterious territory, he offers a unique perspective that breaks away from conventional thinking. He might ask provocative questions. Is there a connection between consciousness and the quantum field? Do we need entirely new scientific paradigms to understand artificial consciousness? His presence would definitely spark debate and get people thinking outside the box. Frank Wilczek is another Nobel physicist, known for his deep work on elementary particles and cosmology. But he's also a fantastic science communicator and loves philosophy. He believes physicists should grapple with big questions like free will and time. For this conference, he can offer a truly cosmic perspective. He can ask, where does intelligence come from? Does the universe itself possess some kind of inherent intelligence or tendency towards complexity? By looking at the grand scale of cosmology and the fundamental structure of matter, he can help us frame the emergence of artificial consciousness. He might explore the conditions under which nature organizes itself into complex, intelligent forms, and then extrapolate that to how we might create or encounter artificial consciousness. It's a high-level, thought-provoking angle. Stephen Smale is a Fields Medalist, a top honor in mathematics. He made groundbreaking contributions to topology and dynamical systems. Think of things like strange attractors, those beautiful patterns that emerge from chaotic systems. He's also famous for his Smale problems, which included mathematical challenges for machine learning back around 2000. He was way ahead of the curve, realizing that math needed to deeply investigate the theoretical foundations of neural networks. His expertise lies in understanding order within chaos and how learning algorithms converge. This makes him perfect for discussing artificial consciousness as a complex dynamical system. He can bring mathematical rigor to the discussion, helping us understand the underlying principles governing potentially conscious AI. Even though he's over 90, he's still active, so they're hoping for his participation. David Mumford is another Fields Medalist, originally known for pure mathematics. But he had a fascinating pivot, moving into computer vision and pattern theory. He helped develop pattern theory, applying mathematical and statistical methods to visual perception. His big idea? Visual understanding is absolutely crucial for consciousness. He tried to model how the brain's visual cortex works using probabilistic models. Imagine trying to describe how you recognize a cat in a photo, mathematically. He connects the dots between mathematical pattern recognition and the very basis of visual awareness. His talk could explore how we represent image patterns and what this means for AI cognitive systems, especially for tasks like image understanding. He might even share insights on brain-inspired computing for seeing the world. Cedric Villani is a Fields Medalist known for his work in optimal transport theory, but he's also a public intellectual. He's actively involved in public affairs and even wrote a report on AI strategy for the French government. This makes him incredibly valuable. He bridges the gap between hardcore mathematics and real-world policy. He can talk about mathematical interpretability, making AI understandable, and the crucial aspect of social responsibility in AI development. How do we ensure that as we build powerful AI, we keep ethics and the public interest in mind? He's known for explaining complex ideas vividly, sometimes called the rock star of mathematics. His perspective ensures we don't just focus on the tech, but also on its societal impact and governance. Jean-Marie Lang won a Nobel Prize in chemistry for his work on supramolecular chemistry. Sounds fancy, but the core idea is how molecules can spontaneously organize themselves into complex structures, like tiny self-assembled buildings. He's a champion of dynamic chemistry. This concept of self-organization is super relevant to artificial consciousness. Think about it. Neurons in the brain are simple cells, but they self-organize into a network capable of thought. Lang's work provides a powerful analogy. He looks at complexity across scales, from molecules to cells to organisms. This cross-scale perspective can help us understand how simple components, like neurons or even AI nodes, can give rise to emergent intelligence through self-organization. It's a beautiful example of bottom-up complexity. Finally, in this group, we have Stuart Russell. While not listed with the top awards here, he's arguably one of the most important figures in AI today. He's a leading expert in AI ethics and safety, author of the Standard AI textbook and the book Human Compatible. His central idea is value alignment. How do we make sure AI goals actually align with human values? This is absolutely critical when we start talking about artificial consciousness. If machines become conscious, what ethical responsibilities do we have? How do we prevent them from acting against human interests, especially if they become super intelligent? Russell's work is about ensuring safety and keeping AI human-centric. He offers vital strategic guidance on navigating this complex landscape. Okay, moving on to the second major group, economics, ethics, and social impact. This is where we leave the purely technical details and start thinking about the bigger picture. Developing artificial consciousness won't just be a scientific or engineering feat, it will profoundly shake up our economy, our ethical frameworks, and society itself. We need experts who can analyze these impacts. This group includes Nobel laureates in economics, masters of behavioral economics, game theory, and institutional design. They help us understand how conscious AI might fit into our economic systems, what ethical dilemmas arise, and how we should structure our societies. Importantly, it also includes perspectives from literature and philosophy to keep us grounded in humanistic values. Let's look at this diverse group. We've got Daniel Kahneman, the psychologist who brought psychology into economics and wrote Thinking Fast and Slow. Richard Thaler, the father of behavioral economics, known for the nudge theory. Joseph Stiglitz, a development economist focused on inequality and globalization. Christopher Pissaritis, an expert on labor markets and automation. Jean Tirole, a specialist in market regulation and oligopoly. Paul Romer, known for endogenous growth theory and how ideas drive development. Then we have conceptual invitations to Amartya Sen, a giant in welfare economics and ethics, and Kazuo Ishiguro, the Nobel laureate novelist whose book Clara and the Sun explores AI emotions. This mix covers everything from individual psychology to global economics and art. Daniel Kahneman is a cognitive psychologist who won a Nobel for showing how psychology influences economic decisions. He's famous for his System 1 versus System 2 theory. System 1 is fast, intuitive, and often biased, while System 2 is slow, deliberate, and rational. A huge part of human consciousness is that messy, intuitive System 1. Kahneman's work reveals the imperfections and richness of human thinking. So, the big question here is, will AI repeat human errors? Can we design AI to avoid harmful biases? Or will AI lacking intuition be fundamentally different? His insights bring psychological depth to the ethical design of artificial consciousness. He's nearly 90 but still active, so likely an interview format. Richard Thaler is the guy behind nudge theory. He showed that humans aren't perfectly rational actors. Our decisions are influenced by context, framing, and biases. His idea is that we can nudge people towards better choices by designing their environment. Now, if we have conscious AI, maybe we need to nudge it too. How do we design environments or incentives to guide AI behavior towards what we expect, like following social ethics rather than just maximizing profit? Thaler's work gives us practical tools for thinking about how to shape AI decisions. He might discuss how AI can overcome or even utilize human-like thinking biases. It's a clever way to think about aligning AI with human values. Joseph Stiglitz is a development economist who has spent decades studying wealth inequality and globalization. He's recently warned that unregulated AI could make things worse for the poor and the middle class. If machines become highly intelligent, they'll reshape jobs and wealth distribution. Think about robots doing jobs, or algorithms making financial decisions. Stiglitz can analyze this transformation from a macroeconomic perspective. He can argue for the need for appropriate regulation to prevent AI from creating monopolies or deepening social injustice. His voice is crucial for reminding us that technological progress must be balanced with policies that protect the public good. Christopher Pissaritis is a labor economist, meaning he studies jobs, employment, and how automation affects work. After winning his Nobel in 2010, he chaired the UK's Future of Work report. This puts him right in the thick of it. With conscious AI, robots aren't just tools anymore. They might become members of the workforce. This raises huge questions. What happens to jobs? How do we measure productivity? What is the meaning of work when machines can do many tasks? Pisarides advocates for a new paradigm of good work, where AI and humans complement each other, perhaps through education and policy changes. His insights blend academic rigor with direct relevance to the real world of work. Jean Tirole is a specialist in market regulation and oligopoly. He won a Nobel for figuring out how to regulate markets dominated by a few large players. This is super relevant now. AI with human-like intelligence could lead to new digital monopolies where a few companies control everything. It also creates ethical dilemmas. Tirole emphasizes the need for smart regulation, rules that encourage innovation but manage risks. He can explore how to design laws and institutions so that artificial consciousness benefits market vitality without harming public interests. His approach considers both the economic efficiency and the moral dimensions of governing AI. Paul Romer is known for endogenous growth theory, which argues that economic growth comes from within the economy, driven by ideas and technology, not just external factors. He sees technology as key to sustainable development. AI is seen as a general-purpose technology, like electricity or the steam engine. Romer can help us frame the long-term impact of AI on productivity and welfare. He might ask, can conscious AI become an idea workforce, generating new knowledge and expanding human innovation? At the same time, he might emphasize the importance of open knowledge sharing to prevent the digital economy from being controlled by a few oligarchs. His perspective links AI consciousness to broader economic strategies. Finally, we have conceptual invitations to Amartya Sen and Kazuo Ishiguro. Amartya Sen, a Nobel laureate in economics, focuses on welfare and ethics. He might ask profound questions about the meaning of artificial consciousness from a philosophical standpoint. When machines have autonomy, how do we ensure their decisions align with human values? His work emphasizes rights and conscience in decision-making, reminding us that AI should ultimately serve human well-being. Then there's Kazuo Ishiguro, the Nobel laureate novelist. His book Clara and the Sun features an AI companion with human emotions, prompting readers to think about machine consciousness. Literature offers powerful thought experiments. Ishiguro could share the inspiration behind his AI characters and the ethical considerations he explored. His dialogue would bring rich humanistic depth and emotional resonance to the conference. So, wrapping up, this list of potential speakers is incredibly diverse. It's not just about building smarter machines, it's about understanding the profound implications of creating artificial consciousness. From the fundamental physics of Penrose and Wilczek, to the emergence of complexity with Parisi and Len, to the ethical frameworks of Russell, Sen and Thaler, and the societal impact analyzed by Stiglitz, Pisarides and Tirole, and the humanistic reflections from Kahneman and Ishiguro. Bringing these voices together ensures the conference tackles the topic from every angle, making it a truly comprehensive and thought-provoking event.